page, we went over how to factor the difference of two squares. And so the number one thing is first look to see if you can't pull out a common factor. And then what remains, if there's a perfect square minus a perfect square, then the open arms where it's like the square root of the first goes in front, square root of the second goes in back, and then the opposite signs make that middle term cancel. So what I'm going to do again is kind of make you prove the factoring that somebody found. So what we're going to do is we're going to distribute, and this is why I hate the word FOIL, because with FOIL, it's only for a binomial times a binomial, where you need to know how to distribute, okay? So on here, go ahead with me, guys. What we're going to do is we're going to distribute A, but we're going to do it to all three terms in this trinomial in the back, okay? So A times A gives you what? Or A times A squared, I should say, gives you what? A to the third. And then A times negative AB is?
Negative A squared B.
Perfect. And then A times B squared is AB squared. Is that all right? So then, are you having trouble finding it?
I don't know why I don't have it. Oh. What is it supposed to look like?
It kind of looks like this one. Right where we ended.
This one. I don't think I have it. How long ago was
Right
it?
there.
Oh, that's it.
It was just yesterday. Okay, so then we're going to do B towards all the things. So B times A squared, do it in alphabetical order so that you can see how things cancel and stuff. So that will be a positive A squared B. Is that all right? And then B times negative AB will be a negative AB squared. And then last but not least, B times B squared will be B to the third. And what you notice when we do all of that, did I do that right? Yeah, so we'll have negative A squared B up front, cancels with the positive A squared B, and the AB squared cancels with the negative AB squared. So when it's all said and done, we're just left with A cubed plus B cubed. All right? We're going to do the exact same thing on the right-hand side. All right? So let's do A times A squared to get A cubed. A times a positive AB will be a squared B. And then A times B squared will be AB squared. Now we're going to go back through, but with a negative B. Negative B times A squared will be negative A squared B. Negative B times AB will be a negative AB squared. And then negative B times B squared is a negative B cubed. And again, when you go back through, you'll see that this positive A squared B cancels out with this negative A squared B. And this AB squared cancels out with this negative AB squared, and it leaves you with A cubed minus B cubed. So what we've done is we've actually came up with the formula scheme for factoring a difference in sum of two cubes. They end up being that factor form that we just distributed, all right? So the rule is, I'm going to try my best to kind of remind you guys, I would never force you to remember this. This is something that it doesn't come up that often, and when it does, you can always use resources to look it up. But for purposes of this class, I just want your notes to be your resource, and so you can quickly see how to do it. So how do we factor it? What's the rule that we're going to put in this box? The first term is always each letter, the cube root of it, right? So we have A cubed and B cubed. So we start with just A singularly plus B singular. And the sign matches what you originally start with. So notice that we started with a sum. So the first chunk is a sum. Then on the back half is this trinomial, and this trinomial never factors. So once you factor it and you have this trinomial, don't try to do AC method with it or anything. It's going to stay as is, all right? So what is this? It's always the square minus the product plus the square, okay? So the square of the A goes in front, the square of the B goes in back, their product goes in the middle, okay? And then what you'll notice about the sign is that it's the opposite of what you started. And I'll point that out when we do the formula over here to the right. There's a little acronym to remember the signs. All right, so when we go to do this, it's going to be very similar. So notice we'll have A and B singularly in front, but use the sign that you originally start with. So since we started with a difference, it had a minus there, we're going to have A minus B. And then the trinomial in the back is the same thing, guys, where you have the A squared in front, a plus product of the AB plus a B squared in back. Okay? So notice they all, like the values A and B are exactly the same, right? Singular, 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 squared, 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 product, product, all right? How can you remember the signs? Remember the acronym SOAP. Same, same, opposite, always positive. So remember SOAP for your signs, okay? So notice this is the same thing. It's the same sign as we started with. Now we use the opposite sign of what we started with, and this is always positive. So that acronym SOAP will always kind of help you remember the signs. Do you have to memorize this formula? No. So you can always look at your notes and pull the signs off of it. But after a while, you guys kind of get the hang of it, and so you might start being able to do it without referring to your notes. So when we go to do these problems, first we have to realize that you can have a sum of two cubes. Remember, you couldn't have a sum of two squares. There's no way to factor a sum of two squares. But you can have a sum of two cubes and a difference of two cubes. Our first thing is going to be, what is our A? What is our B? And then when we get to each of them, we're going to plug it in. So what did we cube to get x? What's the cube root of x? Cubed. Yeah, I'm telling you the answer again, aren't I? What's the cube root of x cubed? X, right? Just like back here, guys, what was the square root of n squared? N, right? So what's the cube root of x cubed? X. So let's just kind of keep that in mind. We cubed x to get x cubed, all right? Now, cubes we're not as comfortable with as we are squares, 4, 16, 25. But does anybody know what the cube root of 8 is?
2.
It is 2, right? 2 times 2 times 2 gets you to 8. If you're not 100% comfortable, get out your calculator. And in your calculator, there's a cube root feature, okay? So on your calculator, it's kind of dark, so I'll turn it on. In your calculator, if you hit the math button, guys, number 4 is the cube root feature, and you can type whatever you want to take the cube root of. So I want to take the cube root of 8, and you hit it, and you get 2. Okay? So you don't have to have them memorized. You can find it. Okay. So why am I saying that? That means wherever I see A, I'm going to be putting an X, and wherever I see B, I'm going to be putting a 2. All right? Oops, I'm too high. Sorry.
I tried to work ahead, but I definitely didn't.
Yeah, this is a little tricky. All right? So I'm going to use the formula. The formula says start with each singularly with the same sign. So what's the singular of x cubed? X. What's the singular of 8? We cubed 2, right? And we used a plus sign because it was the sign we started with. So I'm using this formula right here, okay? The back half, square whatever A is, but what's the square of x?
X squared.
X squared. Use the opposite sign, so we're going to have minus. And then take the product of A times B. Well, what's x times 2? It's just 2x. Perfect. And then square B, but what is B squared?
8. Wait, no.
4, okay? Because what you'll notice is that final distribution, 2 times 4, will get you to that 8 that you originally had. Yep. So it's just the square, because like, here's the square and here's the singular. So when you multiply it, you get the cube. Okay? Does everybody see what I did? Let's just do it again. But the only difference on B, guys, is that it's going to be a subtraction problem. It's going to be this difference formula we're going to use here. But ask yourself, what did we cube to get x cubed? X. What did we cube to get 8? 2. Do not worry about your sign. Your sign simply lets you know which formula you need to use, right? So don't think of -2 or whatever. Okay. So wherever I see A, I'm going to put x. Wherever I see B, I'm going to put 2. All right? So we'll have A minus B, or x minus 2. It's them singularly. What's the cube root of x? Here it is. What's the cube root of 8? Here it is. Then in the back half, we're going to go follow this formula. What is x squared? X squared. Use the same sign, so we'll have a plus. What's the product of A times B? What's x times 2? 2x. And then plus, what is B squared? Well, what is 2 squared?
4.
You got it.
I was ahead on that one. I did it right.
And you got it right. So you'll notice that it matches 1 exactly, except the signs are the different. It's that same opposite, always positive that we're going to do. All right, so this is just going to gradually get a little bit more difficult, but it's not a big deal. So we already know what the cube root of 8 was. It was 2. What's the cube root of n cubed? N. So what's the cube root of 8n cubed? 2n. Okay, so we'll write 2n right below it. Is that okay? So the cube root of 8 got us 2. The cube root of n got us n. What's the cube root of 27?
3.
3. So in this formula, wherever we see a, we're going to be putting a 2n. Wherever we see b, we're going to be putting a 3. All right? So the formula says use each of the singular values first with the same sign. So what was our a? 2n plus our b, which was 3. Is that okay so far? Then we'll go to the back, and this is where we have to be careful. When you don't just have a single term like an n or a 3, but you have a 2n, when we go to square it, we have to square both parts. We have to square both the 2 and the n. So what is 2n squared? And you can even write it like this. Let's make an extra line. Let's write it like that. 2n squared. And then we'll jump to the answer in the next line, okay? Because that's what we're doing. We're taking all of a and squaring all of a, both the 2 and the n. Then opposite sign, what is a? It's 2n. What is b? It's 3. So I'll just show the product right there. I'll move it up. Sorry, my head's kind of in the way. So here's a squared minus a times b plus b squared. So when they start getting more complicated, you might take an extra row to just kind of set it up, right? You know, just like plug the values in and then go back through square and times anything that you can, all right? So this first initial guy, he doesn't change at all. He's going to be 2n plus 3. But what is the quantity 2n squared? 4n squared. Does everybody agree? Square the 2, square the n. You get 4n squared. What is 2n times 3? 6n. And what is 3 squared? 9. You guys did it. And like I said, as much as you might want to, and you guys might not want to as much in this class as if you were taking 116, but we learn all this when we're learning all the factoring methods, like the AC method. People want to do the AC method, and they try over and over again to do the AC method on this back polynomial. Don't. It will not factor any further. So once you factor it, you're good. All right. So what did we cube to get 64? It is 4. What did we cube to get x cubed? X. So what is this cube root? 4x. All right? And then 1 can be a cube, a square, a 100th power. It doesn't matter. So what did we cube to get 1? 1. So our b is 1. All right, so we're going to follow the formula. The formula is subtraction, so we're going to use this formula up here. It's going to be a minus b, but what was our a? 4x minus our b, which was 1. Is that okay for the initial? And then when you go through, remember we're squaring all of a, so if you need to put it in like this, 4x squared like that, write it. Opposite sign, so plus a, which is 4x, times b, which is 1, plus the quantity 1 squared. So here's my a minus my b, a squared plus a times b plus b squared. The 4x minus 1 hangs out in the front, but what is 4x squared in the perfect? Okay, so 16x squared. And then 4x times 1, do you guys all agree that's just a 4x? And then 1 squared is just a 1. So if you guys get and you understand what we're doing when we're squaring all of a or all of b, and you can go right to the 16x squared, that's fine. I just don't want you to forget to square that first number, that 4, or whatever it may be. All right, so we get down here, we're like, okay, the y is a cubed, but the 2 is not a perfect cube, and 250 is not a perfect cube. But what's the number one rule in factoring? What are we supposed to look for first?
GCF.
A GCF. So what can we factor out of 2 and 250?
2.
A 2. So factor out a 2, and when you do that, guys, that will become y cubed, and then 250, if you divide that in half, you get 125. So who's still part of our answer? The 2, right? But then let's ask ourselves, what's our a, what's our b, right? What did we cube to get y cubed? Y. So that's going to be our a. And then what did we cube to get 125? Any guesses? If 4 cubed got us to 64, 5 got us to 125. All right. All right, so the 2 will hang out in front, guys, as we use the difference quotient up here in the top right, okay? So it's a minus b, or y minus 5, in parentheses. And then in the back half, it's going to be a squared, but that's just y squared. Is that all right? opposite sign, so plus, a times b, which is just y times 5, or 5y, plus b squared, which is 25. You got it. Just don't forget that 2. And it's not hard, especially when you know for a fact I'll always have that formula for you, okay? When you go into future math classes, whether that's calculus or whatever it may be, you will always have a chance to look that formula up because it doesn't show up that often. The difference of squares does. So that's why I want you guys to kind of memorize that, you know, square root of the first, square root of the second, opposite sign. This doesn't show up as much. All right, 6, guys, is going to be identical to 5. We just have to factor out that GCF first, and then we're going to use the sum of 2 cubes. So what number can we pull out of 2 and 54? A 2. And what variable can we pull out of a cubed b and b to the 4th?
B.
A b. So we're going to factor out a 2b. When we do that, what's going to be left in that first chunk?
2a squared.
Well, we pulled out the 2, right? So just
A cubed.
a cubed, you got it. Plus, and then what's 54 divided by 2? 27. And we had 4 b's, but then we took 1 away, so we have 3. Okay? So the 2b is going to be part of our answer, but then we're going to go back and say, what did we cube to get a cubed? What did we cube to get 27b cubed? Well, the a cubed part's easy. What did we cube to get a cubed? A. So a will be our a. Is that confusing? A will be your a. Yep. And then 3b will be our b. So what I hate is in these formulas, guys, they use a and b generically in the formulas up top. And I hate when they use a and b in the actual problem because it gets kind of confusing. So 2b will hang out, and then we need a plus b. So we're going to have a plus 3b because a was our a and 3b was our b. Then we go to the back half. We need all of a squared, but our a was a, so what's a squared? A squared. Opposite sign, which is minus, and then the product of a times b. Well, what's a times 3b? That would just be 3ab. Is that okay? You usually put that coefficient in front. And then always positive, right? And then we have to square all of b, both the 3 and the b. 9b squared, perfect. And that's what I was talking about. You guys will get comfortable with that where you can go right to that and you don't have to do that extra stuff in the middle. And I know it's like, this is what blows my mind, guys. As extensive as that is, if we were to distribute the a to this, the 3b to this, and then distribute the 2b at the very end, we get this nice little concise answer. It's just weird how it all works out. Like,